Well, hi everyone. Welcome to today's video where we're going to be talking about the distance on a coordinate plane. In our last video, we did kind of get into this idea of a coordinate grid, and also our ordered pairs, and really what all of that means, right? This idea of a coordinate is location. And so everything has a location. It's just that our world, we don't really see it. We talk about this idea that it's just a plane, like there's this space in which lines are going on forever and numbers are floating around and objects sit upon them. And since we can't see it, like scientists, we like to create models that allow us to make sense of it. And what we've done is we created a coordinate grid. A coordinate grid is that idea of two places. You have your x-axis and your y-axis, is what we were talking about in the last video, as well as in class recently. And how these lines go on forever, where they cross, we call the origin. And the origin is the beginning, right? So 0. And then how like 1, 2, 3, 4, 5, right? We have these number lines that we mark on. And we start to say, oh, well, okay, well, if this was point W, where is it located? Well, its ordered pair is 4, because you always start with your X, and 3. So the ordered pair is 4, 3, right? So that's what we were talking about. Now, today we're going to kind of talk about the distances that occur between coordinate pairs, like what is going on between. And we're going to make a little more sense of that and what that means and how that's actually been kind of work we've been doing this whole time. We just didn't really see it yet. And that's okay, because again, we can't actually really see a plane. That's why we draw a coordinate to help us make sense of it. So let's just kind of play around with that first. I'm going to go ahead and build a coordinate or a coordinate grid. And I'm going to stay quite straight. I'm going to stay within the first quadrant, which is where we have our positive x's and our positive y's. So remember again, x is the one that goes along the bottom. So this would be our origin right here, and that would be 0. So I'm just going to create some tick marks out here to help me measure. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then our y-axis goes up and down. Again, the origin's the same place. It also starts at 0, but this time we have 1, 2, 3, 4, 6. Okay, so let's kind of play around with this first and thinking about when we're talking about the distance on a coordinate plane, we're talking about the distance between two ordered pairs. So why don't we come up with two ordered pairs? So I'm going to go with A and B. And A, let's say I make 4, 6, and B, I'm going to make 4, 4, 2, let's say. Okay, so let's first plot these out, and then we're going to start talking about this distance that we find on the plane itself. So I'm going to start with A. So again, remember an ordered pair is X and then Y. So the first thing I'm going to do is I'm going to move along to the 4, and then I'm going to come up 6. So right 6. So that would be right here. So that would be A. And then if I was to plot B, plot is the term we use for like graphing it, right? So B, it's going to be 4, so the same X, but this time up 2. So B would be right here, okay? So now what we're talking about in this concept then is like, what is the distance that occurs between these 2 points? Like what's happening right here? And the reason why we're looking at it here is because one thing we notice is they're both at 4 in the X. So the X is the same. So we came out this direction, the same distance, right? They're both located 4 units out, right? 1, 2, 3, 4 units out. But what happens here, like how many units take me from A to B or B to A, right? It's kind of a two-way road. So one way we can just definitely look at that is what I just started doing here, which is if I really drew out this whole coordinate grid, I could really be creating the lines that just go on infinitely on here. For example, 3 here on the X, it just goes on forever this way. 2 goes on forever this way. 1 goes on forever this way. That was, oh wait, there, okay. And here's even 0 that goes on right here. And then we have our 6 that goes this way and our 5 that goes this way. And when we do this, actually, you realize this starts to look like something we've been making all year. Look at this. This is just an array right here. We actually have an array of rows and columns, right? We have these columns of 4. We have 4 columns, 1, 2, 3, 4. And we actually have 1, 2, 3, 4 rows as well. And so when we think about, well, what's this distance between the two of them? Well, they're not any further on X. X is the same. But the distance between B and A here is 1, 2, 3, 4 units. So our answer is 4 units when asked what is the distance between these 2 points. And this is kind of messy over here. I'm going to try to clean this up. 4, 6, 4, 2. Because that's important that we look at this, because another way we can look at this here is when we look at our X, we see those are the same. So there's no math that needs to worry there. They're in the same place. They're on the same X, but they are a distance between 6 and 2. And if we think about the distance or the difference between 6 and 2, we actually get 4 as well. And that just proves it mathematically. So we could actually count the units in which happen in between these two, as well as just use the math. That's a lot, as always, like always the first one, right? All this information comes flooding in and like, what does this mean? And what are we doing? So don't worry, like, as always, we just keep practicing to make sense of things. Nothing is gonna make sense the first time. So let's play with another one and go with this. So again, let's build out our coordinate. Again, I'm working just in the first coordinate. The first quadrant, I should say, of our coordinate. Sorry, God, those are kind of crooked, aren't they? Oh, well. Oh, it doesn't move that way. What am I doing? So we're thinking about where we're working is just in that first quadrant where we have positive X and positive Y, right? And we've talked in class about the 4 quadrants, but again, this just helps us make sense of this. So my X, again, here's my origin, the start of it, that's 0, 0, 0x, 0y. And then 1x, 2x, 3x, 4x, 5x, 6x, 7, 8, 9, 10, and 11. So 10, 9, 8, 7, 6, 5, 1, 4, 3, 2, 1. Just getting in a few of these to help me write in all their marks. Okay, and then with the y like the sky. So we're going to do those increments of 1 whole as well. Okay. And so now again, like I said, the reality is we're going to think about when we have 2 coordinate pairs on here. So I'm going to build 2 coordinate pairs. So I'm going to have an X and a Y. And I don't know, let's call it W and the V. Okay. So point W, let's just say, lives on, I don't know, 1, 5. And point V lives on, let's say, I don't know, 7, 5. Okay. So the first thing we're going to do is we're going to plot these 2 points, and then we're going to look at the distance between them, the amount of units that lives in between them. Now, one thing we can already see that is helpful in the beginning of this skill is that one set of our coordinates is in the same place. They're both going to be on the 5y. So that makes it a little bit easier because we're only going to be kind of comparing what's the difference we see in X. But we definitely want to graph first or plot. So W, right? W has that ordered pair of 1, 5. So I'm going to go 1x and then I'm going to go up 5. So that'd be right here. So here's W. And then V is 7, 5. So V lives right here. Now, again, 2 things I could do. 1, since they're both at 5 in the Y, That's the same place. So there is no difference. They're both at 5. But then I could look at, well, what's the difference here between 7 and 1? And the difference between 7 and 1 is 6. So mathematically, the distance between these 2 points, these 2 ordered pairs, is 6 units. But how we visually see that is also really important. So remember, like, we have this is how we draw these grids. But the reality is this is also, these are all just lines that go on forever. It's just we can't see them. So I don't know, we could draw them to see them, but we don't always draw them. But let's just say these lines here that go on forever. We go this way. And these would be like my rows, right? Again, equating this to something we already know, which is an array. And then here would be like my columns. Sorry, that's a little crooked, right? And then, so then we are thinking again, oh, cool. Well, I need to make sense of the distance between this point and this point. So we can literally count the units, the box units. These are just right now, these are just boxes that I can count. And those units could be anything. They could represent boxes. They could represent whole numbers. They could represent centimeters, inches, yards, millimeters, right? It's whatever. Like, if it's a story problem, they're going to tell us that. But for here, mathematically, we can just look at it as these units, these box units. And I'm going to count how many it takes to get from here to here. So I could even show the little jump. Let's show like a little jump to count them. So we go from here to here. That'd be 1, 2, 3, 4, 5, 6. So that's what we got, 6 units. So again, there's a mathematical way of doing this. I can also model it and count through this out. And why we want to do that is because we can start to see again what these units and these arrays represent and how all these things are interconnected. It's really fascinating when we start to get into it. I mean, I'm sure that's maybe just an opinion that's fascinating, but I doubt it. That's just a really cool math thing. All right, so let's just do one more. Again, you can see there really isn't much to it, which sometimes that's the confusing part. It's like, oh, that's it. I'm just looking at the difference between this distance. And the answer is yes, that is just it. But also at the same time, then, well, if that's the case, why am I drawing all these grids? And why am I drawing these input-output boxes? Why am I doing math and drawing pictures and counting and all this other stuff? Like, why is it making it so complicated? And it's complicated because I just want to make sure that we see it and understand why it is what it is. So let's do another one. We're going to quickly label out my X. Oh, nope, we don't want that. We want that one. I'm going to quickly label out X and Y. So here. So here's my X. So 1, 2, 3, 4, 5, 6, 7, 8, 10. 6. Okay, not the prettiest coordinate. I apologize for that. And this time I'm just gonna put some more. Let's just see here. Let's go here and here. And let's call this R. We'll call this S. Okay, so again, we found these, but what we first need to understand is what is the coordinate pair of R. So if we look for R, we see again, as always, X and then Y. So R is right here. It's just lined up with this 4 here, right? I'm going to do this dotted line so we can see it. And then over here, it's actually 4 with the Y as well. So our ordered pair is 4X, 4Y. And S has an ordered pair of 4X, so it has the same place, but this time it has 1Y. Okay, so mathematically, we can see, well, they're the same in the X. So I'm not going to worry about that, but I am going to find the difference in the Y, and the difference in Y is 1 and 4. So the difference of 4 and 1, or 4 minus 1, is 3. So the answer to, like, what is the distance between the ordered pairs R and S? Well, it's going to be, I don't know why I put the word units first. It's going to be 3 units, right? So that's the mathematical part. But again, visually, how do we see this? Well, again, we can just say, oh, well, these points, these lines, they go on forever, and we can draw them so we can see them, because we can't see them. That's why mathematicians have drawn these to help us see them. And then what we get out of that, if we look, is we actually see we're getting a shape out of this. And that shape is also made of rows and columns. And if we just count it, then the amount of units I have here, I have 1, 2, 3, then we also again see how 3 units visually is the distance, because those units here, I don't know, again, each maybe one of these is actually equal to 1 centimeter. So then my answer would actually be 3 centimeters or 3 units, right? Okay, so that's what we're doing. I know, and I can understand if this still feels like a lot, it still feels a little confusing, that's okay. We are just really thinking about where are these points on a plane and what is the distance between them and what are the units? And the units are these boxes, which are the same things that we've been drawing all year in terms of rows and columns and the idea of making an array. That's the fun part about it. So with that being said, I'm going to leave you at that. Of course, you know there's more to come, and always ask questions. That is our math norm. Ask questions so it makes sense. And remember, it's not about getting it right away. It's about exploration, making errors, and having fun and learning from it, and practice, practice, practice. We'll see you next time.